Hey guys, welcome to question MM442 of the Maths Methods Fortify study guide. So in this question we've got the metal company, very original name. MC produces metal poles used in scaffolding for construction companies. The length of their poles are normally distributed with mean 2.2 meters and standard deviation of 3 centimeters. A pole is considered long if it has a length of 2.24 meters or more. Awesome. Part A, which is a 2-mark question, says what percentage of the poles produced by MC are considered long? Give your answer correct to 2 decimal places. So we're looking for the amount of long. Awesome. So we know that it's normally distributed, so what I would do is just create a normal distribution curve quickly, where our mean is 2.2, our standard deviation is 3 centimeters. Please don't get confused with meters and centimeters. They need to be in the same units, right? So from here, we know that it is long if it has a length of 2.24 meters. So let's say that we've got our 2.24 meters here, and everything above here is considered long, okay? So what we need to do is figure out the area or the probability above this point here. And how do we do that? Using our normal CDF. So we go into our CAS and say our normal CDF, it's going to ask us for 4 things. So lower, upper, mean, and standard deviation. Now our lower is our lower bound point, which in this case is our 2.24. Upper bound is our upper bound. We don't have one technically, so in this case our upper bound is going to be infinity. Our mean is 2.2, as we know, and our standard deviation is 3 centimeters, which means that it's 0.03 meters. Okay, so don't get confused with that. You got to make them the same unit. Now, what we actually get then is the probability that x is greater than or equal to 2.24 is equal to 0.0912. That's our first mark. But the question asks us for the percentage of poles, okay? So this is our decimal, and changing that into a fraction, we just take the decimal over by 2 points. Oops, that was 3. By 2 points to here, which means that we get 9.12%. Of these poles are long. This is our second and final mark for part A, and that's it. So guys, let's move on to part B. Part B is a 2-mark question as well. Very, very similar concept to part A. This question is really just about reinforcing your ability to find probabilities and to identify how to actually do that. So, part B says, the most popular pole is MC's medium pole, which has a length ranging between 2.16 meters, so medium, is 2.16 to 2.24. What is the probability that a randomly chosen pole produced by MC is of medium length? Awesome. Now, again, we know that the curve, I shouldn't have wrote that out actually, the curve is like this, 2.2 is in the middle. We're looking for the probability that it lies between 2.16, which is here, let's say, and 2.24. So we're looking for this probability in between here. Now, there's multiple ways we can do this, but the way that I'm just going to show you is if in part A we found that the probability that x is greater than 2.24 was equal to 0.0912, which means that the probability that it's less than 2.16 is also 0.0912, right? Because it's symmetrical, okay? So this is the same distance away as this. Which means that this bit in between here is going to give us what we need. Okay, so that's our first mark, recognizing all that. I've done this differently in the work solutions, but this is just a different way of explaining it. So we know that the total area has to be equal to 1, which means that our probability that we're looking for between here is equal to 1. So the whole thing minus 0.0912 minus 0.0912. Which is equal to 0.8176. So that's the probability that we get a medium pole. This is our second and final mark. So guys, that's it for part B. Let's move on to part C. Part C is a little confusing, just the way that it's worded. So let's go through it. It says, a stack of 20 mixed poles containing long, medium, and short poles, where short poles are all poles shorter than 2.16 meters, is chosen from the construction site at random. What is the probability that at least 5 of these poles are not medium-sized? Okay, so we're looking for the probability that at least 5 of them are not medium-sized. Okay, so where x is not medium, right? Now, we know that the probability that it is medium according to the previous part in our question, the probability that any given pole is medium is 0.8176, which means that the probability that one of them is not medium is 1 minus that, right? So the probability that we get not medium, equals 1 minus 0.8176. And this is equal to 0.1824. So the probability that any given pole is not medium is 0.1824. And we're looking for the probability that at least 5 of those 20 are not medium, right? Which means, and this is actually our first mark here, which means that we need to use our binomial CDF again. So binomial CDF, we're going to be asked for lower, upper, NP. So our lower is 5, right? Because we're doing at least 5, so it includes 5, so our lower is 5. Upper is 20 because we've taken a stack of 20 mixed poles. Our N is 20 as well because we've taken a stack of 20. And our p-value is the probability that any one is not medium, right? Which is 0.1824. This is our second mark. Our third mark comes from actually doing this. So this gives us the probability that x is greater than or equal to 5, which is equal to 0.2949, which is our third mark. A lot of this is actually interpreting the question in terms of the marks that you get. It's just actually figuring out what to do, and that's what kind of gets you the mark. So that's it. If you have any questions, let me know. But let's move on to part D. Part D is a 3-mark question as well. And what it says is the head office of MC look at some sales figures and decide they need to manufacture a higher proportion of the more popular medium poles. This means they need to install new machines in the factory. These new machines produce poles with mean 2.2 meters and standard deviation sigma. Sorry, I couldn't think of what that symbol was called. So actually, let's just remove this. So the mean is still 2.2, but our standard deviation is sigma at the moment. We don't know what that is. Sigma centimeters, let's say. Find the value of sigma correct to the nearest millimeter if 90% of the poles manufactured are to be medium poles. Awesome. So what this means is we have our 90% of medium poles, which lies in here, so 90%, which means that everything less than that is going to be 5%, and everything greater than that is going to be 5%, right? So these are our medium poles in the middle here. Still a mean of 2.2, but we're looking for the value of sigma, so our standard deviation. Now, we know that these points here have a corresponding x value. It might be 2 or 1.9, not too sure yet. But it also has a corresponding z value, right? And the way that we're going to work out our standard deviation is using this formula z equals x minus mu, mu over sigma. We don't know what this is. We do know what this is, but we need to find out what our z value is as well, all right? Now, what are we going to do here? Well, we know that our area above this point here is 95%, so our 90 and our 5, which means that because we know our area, but we're looking for our z value, we're going to use our inverse normal. So inverse normal asks us for area, mu, and sigma. Area is always, in inverse normal, the area to the left, as I'm sure you're aware by now. So our area to the left of this point is 5%, which is 0.05. We're looking for our z value, which is our standard normal distribution. So our mean is 0, standard deviation is 1. What we get here is z equals negative 1.645. This is our first mark. Now, this z here is this, right? Now, we know that medium poles are between 2.16 and 2.24. I don't know why I said that could be 1.9 or 2 before. I was just having a bit of a mental breakdown, I think. But these definitely have to be between 2.16 and 2.24. So what that means is we know that our z value is negative 1.645 equals our x value at this point, which is 2.16, minus our mu, which is 2.2, and we know that our sigma is the value that we're trying to find. This is our second mark, and now we can just rearrange this for sigma. Sigma means that we get 0.0243 meters, which is equal to 24 millimeters, because our question asks us to find it correct to the nearest millimeter, which means that this is our third and final mark for part D, guys. If you have any questions about it, just let me know, but let's move on to part E for now. Part E is a pretty straightforward question. It's just a 1 marker, and it says, find the probability that a randomly chosen pole manufactured by this new machine will be a short pole, correct to 2 decimal places. Cool. Well, if 90% of them are medium, that means that 5% of them must be short and 5% of them must be long, which means that the probability that we get a short pole is 5%, which, correct to 2 decimal places, is 0.05. This is our first and only mark for this question. Pretty straightforward. So let's move on to part F. Part FI is starting to move us into statistical inference. So this is just a 1 mark question. And it says the quality assurance, can I get rid of this? Yes. Part FI says the quality assurance inspector at MC takes a sample of 1,000 poles to make sure that everything is running smoothly. The inspector wants to estimate the proportion of these poles that are considered to be short. The inspector finds that in this sample, 57 of the poles are in the length range to be considered short. Determine the 95% confidence interval for the inspector's estimate of the proportion of interest of short poles. Give your answer correct to 3 decimal places. Awesome. So we know that a confidence interval is equal to p hat minus z outside of p hat 1 minus p hat over n, p hat plus z, p hat 1 minus p hat over n. Now, you can do this in your CAS, okay, because this is a 1 mark question, and you have your calculator available to you. So what I would suggest doing is grabbing your calc. Hopefully mine's turned on. Yep. So grabbing your calc and going menu 6, or this is 6 in mine, but statistics, confidence intervals, which for me is number 6. And then we want 1 prop Z interval. So our successes in this case was 57, right? Because our proportion was 57 over 1,000, right? So our successes is 57, our N is 1,000, and we're looking for a confidence level of 95%. So we put a confidence level of 0.95. That's what that looks like there. Hopefully you can see that. And we just click enter. And what we get is this C lower and C upper, okay? And that's the lower and upper bound of our confidence interval. So that means that our confidence interval, according to this, is 0.0, how many decimal places? We need 3. So 0.043, 0.071. And this is our first and only mark for this question. Guys, if you wanted to do this by hand, I don't know why you would, but let's say this was a 2 mark question and you had to do it by hand. Our proportion is 57 on 1,000, that's that bit there. Our Z value corresponds to our 95% confidence interval. So this would have been 1.96, and then our N value is simply 1,000. And if you sub that into there, you would end up getting this. Guys, that's it for part FI. Let's move on to part FII. Part FII is a 2 mark question and starts dealing with margin of errors. So what it says is, in a separate sample taken months later, the inspector takes X poles and conducts the same test as in part FI. The proportion of short poles is still 57 in 1,000 in this sample. So the p hat is still 57 on 1,000. Determine the value of X such that the margin of error for this quality test is 2% in a confidence interval of 95% for this proportion, correct to the nearest integer. Cool. Well, we know our margin of error is given by Z outside of root p hat 1 minus p hat over n. We know that our margin of error is 2%, which means our margin is 0.02. We know that we're looking for a 95% confidence interval, which means that our Z value is 1.96, because that's what that corresponds to. That, just like general knowledge, you should know that. And if you don't, you do now. So Z is equal to 1.96 when you've got a 95% confidence interval. Our p hat is 57 on 1,000, which is the same as 0.057. And we have outside of 1 minus 0.057 over n, which in this case is x, right? We don't know how many we've taken in this sample. So our n value is x, and this is what we're trying to find. This is our first mark, and what we're going to do from here is solve for x. So what you should do is go through all this working. So you get 0.02 over 1.96, and then you'd square both sides to get rid of that square root, so you'd end up with that squared. 0.057 outside of 0.043 over x. And then solving this for x, we would get 516, which is closest to the nearest integer, which is exactly what we need because the question asks us for that. Guys, this is our second and final mark for part FII, and that actually wraps up, does it? Yes, that actually wraps up MM442. So guys, if you have any questions about any of this, please let me know in the comments below. But otherwise, thank you very much for watching, and I'll see you in the next video.